11, the graph of this is shown where a is a constant. What is the value of a? So we have y equals 2 to the x minus a. And we want to know the value of a. So what I would do here is I'd plug in. I've got a graph. I've got part of an equation. I know, for example, when x equals 0, that the function should equal negative 3. So let's plug that in for x and plug that in for y, and then we can solve for a. So I get negative 3 is equal to 2 to the 0 minus a. Anything to the 0 power is 1, so now I have an equation that I can solve. So I get negative 4 is equal to negative a, so a is 4. And if you plugged in any other point that was on this function, you get the same thing. So 11 is a. 12, for a certain group of fish, the graph models the relationship between L and A. Which equation represents the relationship between length and area? So what I would do here is just pick a point off of the graph, plug it in, see which one works. For example, when I plug in, let's do L is 15. Although, let's pick a number that's easy to square because I don't have a calculator here, so I do need to try to pick an easier number. I'll just do 10. This is fine. When I plug in 10, I should get something like 3-ish or so. So let's plug in 10. So for this one, I'm going to get 0.02 times 100. That's 2. It's pretty good, pretty close to 3. All the others are going to be way too big. This is 123. This is 202. This is 323 when I plug in L as 10. So out, out, out. So the only one that works, choice A. 13, system of equations, got to solve for x here. Somewhat annoying coefficients. I wonder, so 8x minus 4y equals 7. Normally, you would sort of multiply both equations by something. But I see that I have an opportunity to simplify this. So, there's a lot of ways to go about this. I'm going to choose to divide this through by 3 just to simplify that equation because I feel that's going to make my next steps a little bit easier. So I get this. Now I want x, so I want the y's to cancel. Let's multiply the bottom by positive 2. So let's rewrite this. 8x minus 4y equals 7. 2x plus 4y equals 8. So the whole reason I multiplied by 2 is that when I add these equations, the 4y's cancel. So I get 10x equals 15. So x is 1.5. Indeed, they wanted x. So 13 is A. 14. We have a system that has exactly one solution, which could be the value of k. So first thing I would recommend here, since these are both equal to y, let's just set these equal to each other. And what is going to make this have one solution? Well, let's kind of test the scenarios. If this is 2, and I try to solve this, what happens? Well, I subtract 2x from both sides. I get 5 equals 3. Which doesn't make sense. What this means is this particular system has no solutions. These are actually two parallel lines. They never intersect. So that is not an answer, so I can get rid of A and C. Then what about 5? So I will get 2x plus 5 equals 5x plus 3. And if you try to solve this, we get 3x is equal to 2. I get x is 2/3. That's a solution. So this one has indeed only one solution. So that could be an answer, could be a value for k. And so 14 is B. 15, this function models the number of flower beetles in a certain area. T represents the number of days after June 1st. What does this mean? Okay, this is an exponential. This number right here is the initial value, in this case, of the flower beetles on June 1st, more or less, at the beginning. That's the number of days after June 1st as they've defined. And this right here tells us the rate of growth. It represents 1 plus R, where R is the percent increase per time period, which in this case, since we have T in terms of days, it's 11% increase per day. So the model predicts that there were approximately 1.11 flower beetles. No, the initial is 100, not 1.11. Does it increase by approximately 1.11? Well, by a factor of 1.11. It'll multiply by 1.11. Doesn't increase by 1.11. The model predicts that it will take approximately 1.11 days for the thing to double. This is not a doubling period, but I like D. The model predicts that the number of flower beetles grows by a factor of approximately 1.11. In other words, you're multiplying your number of beetles by 1.11 for every day that passes. So that means 15 is D.